Hello students, question number 36 of part test 2 is a 2-mark question from design of RCC structures from basic elements of pre-stressed concrete. Now in this question, a rectangular concrete beam of dimensions 250 mm into 600 mm is given and it is pre-stressed by area of steel of 616 mm square and effective stress in wire is 700 Newton per mm square. And these wires, they are located at 200 mm from soffit of the beam as shown in figure. That means from centroidal point the eccentricity of this P, that is the total pre-stress force, will be 100 mm, as a result of which moment because of pre-stress will be coming out as P into 100. So first of all we will find out P because this is the value of stress that is given. So area of beam comes out as 250 into 500, that is 15 into 10 to the power 4 mm square. Now we know that for rectangular section Z is BD cube by 12 upon D by 2, which comes out as BD square by 6. B is 250, D is 600, and so it comes out as 15 into 10 to the power 6 mm cube. Now area of steel is given, value of stress is given as 700. So total pre-stressing force comes out as 431,200 Newton. And as we already talked that this is acting at eccentricity of 100 mm, that's why total moment will be P into E, and if we divide this moment by Z, we will be getting the pre-stressing total, not total pre-stress, the pre-stress that is acting because of eccentricity of 100 mm and pre-stress on cross section, stress on cross section because of this pre-stressing force will be P divided by area, where A is area of beam given by 250 into 600 and P is we already calculated is 431,200, so it comes out as 2.87 Newton per mm square. So total pre-stress is 5.74 Newton per mm square, which will be introducing compression at the bottom fiber of the beam. That is the basic fundamental on which pre-stressing is based, that in simply supported beam having uniform distribution load acting in downward direction or concentrated load acting in downward direction, we have tension at the bottom. So pre-stressed beams are designed in such a way that there is some release of tension by introducing compression at the base, as a result of which total pre-stress that will be compressive in nature comes out as 2.87 plus 2.87, which is 5.74 Newton per mm square. And to have effective tension at 0 at the base, we can have tensile stress because of external loading, which is given by M by Z equal to total pre-stress acting as compression, so that C should be equal to T, resulting in 0 stress at the bottommost fiber, which gives M as 86.1 into 10 to the power 6 kilo Newton. If we talk about the diagram, that from where it comes, if you recall, we know that because of uniformly distributed load, stress distribution is something like this. Here we have T, here we have C, and because of eccentricity, it is C, it is T. This is for UDL, and if we apply pre-stress, we will be having compression throughout, and because of some eccentricity that is present in this case, this C and T will change its position, as a result of which it will be C plus C, 2C type because of eccentricity plus 1T, and here we have to design section in such a way that this C plus C should be neutralizing this T, as a result of which bottom fiber should be having no tensile stresses at all. So the correct answer is 86.1 kilonewton meter, making C as the correct option. Thank you.